Okay, today we're going to look at probability. So there's two types of probability you've got to focus on. The first type is what we call experimental probability, and that's when you're calculating results based off of something that's actually happened, and then you've recorded what has happened. So like if you roll a dice 16 times, or if you flip a coin 23 times, and you're actually recording the results and then using those results to calculate your probability. Then there's what we call theoretical probability, and that's what we calculate based off of what we think will happen. And so each of those probabilities has a formula for calculating it. So the experimental probability is what happens. I got to figure out how to draw in here. Nope, that didn't do it. Experimental probability is what happens when you take the actual number of outcomes that you're looking for divided by the number of trials. And then theoretical probability looks at dividing the number of favorable outcomes divided by the total number of outcomes that are possible. So we'll look at a couple of examples to see how this plays out. So here's the first example. Let's say I roll a dice 12 times. Based on the results that we see below, find the experimental probability that I roll a 4. So in that probability, we can see that there are 1, 2, or that example, 3, 4. There's 4 4s. So the probability of rolling a 4, this is going to be messy, sorry, it's going to be 4 divided by the 12 possible, the 12 trials that I did, and then I could reduce that to equaling 1/3, because 4 out of 12 reduces to 1/3. So the probability of rolling a 4 in this experiment was 1/3. All right, so now let's talk about theoretical probability. So in my first example, what's the probability of rolling a 4 on a standard 6-sided dice? So if I'm rolling it one time, what's the chance of rolling a 4? Well, then you're going to look at the outcomes that are possible. 1, 2, 3, 4, 5, or 6. There's 6 different outcomes possible. The favorable outcome is 4, and there's only one way to get a favorable outcome. So the probability of rolling a 4 would be 1, because there's only one favorable outcome, divided by the 6 different outcomes that are possible. It looks a little bit different if you roll the dice twice. If I'm rolling the dice twice and I ask what's the probability of, say, rolling 1 4 and 1 3, now we have to be careful because there's a lot of different options that are possible. So it's helpful to think about my dice in different colors. So think about it if you have a red dice and a white dice. Now it could happen that the red dice turned up 3 and the white dice turned up 4, or that could be reversed where the red dice was 4 and the white dice was 3. So there's actually 2 different ways to achieve a favorable outcome. And in this case, there's not just 6 possible outcomes, but 36 possible outcomes shown by the different pictures that you see here, right? So we've got 6 going across the top, we've got 6 going across the bottom. 6 times 6 is 36. So there's 36 different outcomes here. So that means that the probability, excuse me, the probability of getting a 3 and a 4, well, there's 2 ways for that to happen, divided by 36 total ways, and then you could reduce that. 2 over 36 reduces to 1 over 18. All right, so now let's talk about probability and the multiplication rule. The multiplication rule, the best way to remember when to multiply is when you see, whoopsies, sorry about that, see this word and. And means multiply in probability problems. This is when you have more than one thing occurring. So both things have to happen either at the same time or one right after another. So for example, if I want to find the probability of rolling a 3 on a dice and flipping heads on a coin, I would multiply those 2 probabilities together. So the probability of rolling a 3 is 1 out of 6. The probability of flipping heads is 1/2, 1 out of 2. But the probability of flipping a 3 or rolling a 3 and flipping heads would be 1/6 times 1/2, or 1/12. Now, in addition to the multiplication rule, we also have the addition rule. And the addition rule is when you have or events. You're going to add probabilities together when one thing or another thing can happen. So, for example, if I wanted to find the probability of rolling a 3 or rolling a 5 on a dice, this is if you get just one roll, then I'm going to take the probability of rolling a 3, that's 1/6, times the probability, and the probability of rolling a 5, 1/6. I'm going to add those together. So the probability of a 3 or a 5 is 1/6 plus 1/6, which is equal to 2/6. Then I'm going to reduce that 2/6 and get 1/3. And then we have independent events. So it's important to know what independent events are because they affect how you're going to do your probability calculations if you're looking for multiple events occurring. So we say that two events are independent if one happening does nothing to change the probability of the other thing happening. So for example, if I flip a coin twice, the probabilities don't change. Just because I flipped it once has absolutely no effect on what the outcome is going to be the second time I flipped it. Or if I roll a dice and flip a coin. Rolling the dice has absolutely no effect on the outcome of what the coin is going to be when I flip it. So those are some examples of events that are independent. Some people like to use the word dependent for the other kind of events, but I don't think that dependent is the best language. I prefer just not independent. So here's an example. If you're familiar with playing cards, cards have different suits and different colors. So the suits are hearts, diamonds, spades, and clubs. But the probability of pulling 2 hearts in a row from the deck, those are not independent events because once I've pulled the first heart, now there's fewer hearts left in the deck, so the total number of outcomes has now changed, and so the probability would change. Another example is if you have a drawer of 10 black socks and 6 gray socks, the probability of pulling 2 black socks in a row. Those would not be independent events because as soon as I pulled that first black sock out of the drawer, now there's only 9 black socks left to choose from, and so the probabilities will change. So here I wanted to do an example of pulling out a matching pair of socks. And so what we need to think about here is how could I possibly get a matching pair of socks. So either my socks are going to be black or they could be gray. Now when I pull my black socks, the probability that the first sock that I pull would be black is the number of favorable outcomes, which would be 10, divided by the total number of outcomes. And it looks like there's 10 black and 6 gray socks, so that's a total of 16 socks, right? So the first black sock, the probability that I pull it would be 10 out of 16. But then I also have to pull another black sock. So I have to pull the first one black and the second one black. So that tells me I'm going to multiply. Now there's only 9 socks left in the drawer. And there's only 9 black socks left in the drawer. And there's only 15 total socks altogether left. So the probability of pulling a black sock would be 10 out of 16 times 9 out of 15, and you'd multiply that and you'd get some big numbers. I don't know what they are. Then we can do the same thing with gray socks. Alright, so the probability that the first sock I pick is gray is 6 divided by my 16 total socks. And similarly, now if I've pulled that first one gray, now there's only 5 gray socks left in the drawer, and there's only 15 socks left altogether. Then what I would do to calculate the probability of getting a matching pair of socks is I would add these two products because either my 2 socks could be black or my 2 socks could be gray. And when I have an or, I'm adding the probabilities together. So with fractions, you'd multiply across the top, multiply across the bottom, numerators and the denominators, and then you're going to add those 2 fractions together to get the total probability. And that's it. Now, with geometric probabilities, these problems are actually super easy if you know how to calculate area. So when you're doing geometric probability questions, all you want to do is figure out what your favorable area is, and I'm calling that A here. So the probability of landing in the space A is equal to the area of A divided by the total area. So here in this example, if I want to test a question, if I was randomly throwing a dart at this board, what's the chance that it would land in one of the 2 red circles? Well, what I would first do is find the area of each circle. And the area of our circle is pi r squared. So I'd take the radius 2, I'd square it, get 4, and multiply by pi. And then I'm going to approximate that with a decimal, and I get about 12.56. Then I'm going to find the area of the rectangle, and that's just base times height, so that's 12 times 8, or about 96 square feet. So if I were to randomly throw a dart at this dartboard, the probability that I'd hit one circle would be the area of the circle, 12.56, divided by the total area, 96. And if I do that division, I get about 0.131, or about 13%. But if I want the probability of hitting either circle, I either could multiply that by 2 or just add it to itself, right? Because it's this circle or that circle, so that tells me to add. So it would be 0.131 plus 0.131 or 0.262 would be the probability of hitting either circle if I was going to randomly throw a dart at the board. And that's it for our quick review of probability.